Okay, so we have our root class student for this example. We're going to set up an array management system for a course that contains an array of students. So here, this is going to be our base class. We're going to have a subclass, class U for undergrad, student, extend student, and we're going to have another one for graduate student, G student. Okay, we'll fill these in a minute, but what we're going to start off doing is our manager class, our wrapper class for all these. So we'll make a new one called class manager, okay, because we're very creative. So class manager is going to have as its data a string for course name and an array of students. So student S student array S. Fine. All right, and so in our constructor for this, when we create the class manager object, we're going to give it a string, call it course name, and a size, int size, for the number of students. Okay, so course name for course name, and size for class size. Okay, so we'll say this dot course name S equals new student with size. Okay, so that's all we're going to do. We're going to create a new course with some array of students. Okay, and for this, we're going to use synthetic data, right, where we just randomly assign all the people. So in order to do that, we're going to pull the random class from java.util. And that will allow us to have random variables. Okay, so our basic structure, we're going to do the first thing. First, create the class manager object. Second, fill out the student array with synthetic data. And then last, I don't know, we can print the output. So you can verify what all is going on in here. So the big point of all this is going to be a class. This class will contain an array of the superclass type, and that will that contains objects of both subclass types. Okay, so U student and G student. Okay, so that's what we're going to do. So let's go back to our student class. We're going to do these basic things. So student has some standard data. It's going to have a string name, and it's likewise going to have 3 exam scores. So exam 1, or int exam 1, int, put them all in one line. Okay, and then we'll have another variable for the course grade. So we'll call that a char for grade. Okay, and every student's going to have those 3 things. But what we're going to do, we're going to have not have these methods defined strictly in student. So they're going to exist in student, but we're not going to do anything with them. So first one will be void calculate grade. We'll call it compute grade. Okay, and it's not going to do anything in the student class, so we don't have to worry about that. But we're going to override it for both graduate student and undergraduate student. So graduate student, we're going to override the compute grade method. the inherited compute grade method because we get it from student. And we're going to do it as follows, right? So very simply, we're going to use a 10-point scale. We're going to average the 3 grades and use a 10-point scale. So void compute grade, we'll have this here. And we'll do 3 things. So first of all, average the grades. So int sum equals exam 1 plus exam 2 plus exam 3. Okay. And because, again, all of these exam grades, they get inherited from students. So they're going to be there. That's fine. Then we can do our cutoffs, right? So for this, we can define a set of cutoffs, or we could put them somewhere else if we wanted. But we're going to say for this, if sum is greater than, we'll keep it real simple. If sum is greater than 80, grade equals P for pass, else grade equals F, right, for flunk. Okay, we'll do a similar thing for U student for computing grade, but a little different. So first of all, we're going to find out what the smallest one is. Okay, so we're going to say this. If, well, we can use the math. Well, let's just do it. If exam 1 is greater than exam 2, and exam 1 is less than exam 3, then sum equals exam 2 plus exam 3. So we're going to have this sum here. And sum. Okay. Else, if exam 2 is less than exam 1 and exam 2 is less than exam 3, sum equals everything except exam 2, exam 1 plus exam 3. Else, sum equals exam 1 plus exam 2. Okay, so this is our thing. So this first one checks if exam 1 is lowest, use other 2 grades, right? The second one we're saying else if exam 2 is lowest, use other 2 grades. And then last, else use the first 2 grades. Okay. Exam 3 is at least, is no greater than either one. Okay. So this first one we're saying if exam 2 is lower than both of the other grades, we're going to use the sum of 2 and 3. Here we're saying if exam 2 is lower than both of the other grades, we're going to use exam 1 and 3, and otherwise we're just going to sum up exam 1 and 2. Okay. Now again here we'll have a total grade from 0 to 200. Instead of here we had, you know, from 0 to 300. So 0 to 200, this should be sum is greater than 240. Let's make that a little bit tougher cutoff there. For here, since there are only 2 grades, we'll say if sum is greater than or equal to 160. Okay, we'll do greater than or equal to up above here. Passing cutoff is 80% equals 240 points. Here, we're going to say, once again, passing cutoff is 80%. Here equals 160 points. Okay, so that's it. We have different grade computation schemes. Now, next thing we're going to do, let's fill up our synthetic data. So we have all these. Right, we can call compute grade for each one of them and then look at what the grades are. So let's go to class manager. We're going to synthesize some data. So we'll have a loop through. First, we'll create the class manager object itself. So we're going to call class manager. We'll send along a string. So string could be IDS 401, which is one that's split graduate and undergrad. and the course size will stand along. Let's say there's 50 students in it. Okay, so class manager CM, it's a new class manager object with those attributes. For IDS 401 with 50 students. Then we're going to fill out the array with synthetic data. So we're going to run a loop through CM, and we're going to pack it full of data. So for int I equals 0, I is less than CM dot, what's it called, S dot size, S dot length, I plus plus, right? So for every entry in CM's array of students, we're going to give it some synthetic data. So first of all, we're going to say S at I equals new student. Well, we're going to do a thing with this. So we're going to first of all create a random variable. Okay. So random R equals new random. All right. So then we'll say, we'll call up the next Boolean, we'll do true false. We'll do about a 50-50 split for the course. So we'll say if R dot next Boolean, okay, then it's going to be an undergrad student. So a new undergrad student. Okay, cm.s.i. Else cm.s.i equals new G student. Okay, so 50-50 shot. If we take a random Boolean, if the Boolean is true, we make it an undergrad student. If the Boolean is false, create it a graduate student. So randomly assign student type. If random Boolean is true, undergrad student, otherwise graduate student. Okay. So that's the first thing. We've filled out that. Now for each student, we have to give some random exam scores. So let's give some random exam scores that are typically around 80%. So I'm going to say cm.s. Exam 1 equals, we'll make for this first one a random integer averaging between 70 and 90. Okay, so equals 70 plus r dot next int, and we're going to do 21. Okay, so our range here, range 70 to 90, because r dot next int 21 returns a random number between 0 and 20. Could be 0, could be 20, could be something in between. Okay, next one, let's do, this one could be a little higher, this one could be a little lower, whatever. So this one, let's do from, let's just add 5 more to it. 75 to 95, so make that 75, boom. And this one we'll make a little lower. We'll do, I don't know, 60 to 80. People slacked off and didn't study hard for the final, so it's going to be an average 60 there. Okay, so there's going to be a bunch of failing grades and it'll be sad, but there'll be more for the graduates than they are for the others. Okay, so this is part 1. We've assigned all the random data. Now, if we wanted to, we could calculate grades. Go ahead and do that. So we could also say cm.s i.compute grade. And we can do this, remember, because every object of the superclass, every object of student, is by definition going to have a compute grade method. However, because of this polymorphism thing, these objects that we're actually referencing in the array, none of them are student objects. They're all either G students or U students, and they're going to use the class appropriate version of the method. So if it's a G student object, it's going to use G student's version of compute grade. If it is, that's weird that shifted over. If it is an I student, or a U student rather, it's going to use U student's version of compute grade. Okay, let's save that. So, okay, well, let's move on a little bit. So we've got the grades. Now, the next thing we can do once we're all done is we can look at all of the failing grades. So, well, let's just print out everything. So, first thing, print the output. So, string, oh, we wanted to give it a name too. Let's see. And the name, cm.si.name equals, we'll give it a name either U or S. So we'll say, let's make this, we're going to put it in here. Okay. Okay, so we're going to do something here. We're going to say name for the student is going to be U student plus whatever. So cm.si.name equals U student plus I. Okay, likewise for this one, it's going to be G student plus I. Okay, and so now we're set. We can print all the output. So let's make a string for each one. Okay, so for int I equals 0, I is less than cm.s.length. So we're going to go through the entire array. And for each entry in the array, we're going to create a string that contains all the relevant information. So we'll start off string s equals cm.s dot name plus, and we'll do a tab character plus cm.s.i exam1 plus exam2 plus exam3 plus and then grade. I can just put it all on one line, I guess. I just didn't want to. It gets a little long. Okay, but it fits on one line for me. That's fine. Okay, and then for each of those, that's what we're going to print out. So we're going to print out system.out.println s. Okay. So let's see how this goes. We also probably want to print out the average, is what I think we want to do. So I'll print out the total. S plus equals a tab character plus, this is an interesting thing. If I want to get the 3 grades, well, they're already there. But if I wanted to get the 3 grades, I could do a different, I'm just thinking out loud here. We'll do something, there's another thing I want to work in anyway. So we'll leave it here for now. We'll go. That's strange. Oh, exam 1, right? I gave him 0s for the other 2. Aha. Okay. No, we should put in the T's there, huh? Let's move that. There we go. Okay, now let's run that. Okay, better. Okay, so here, let's see. We can look at, here's a graduate student. Well, there's a lot of graduates. What are the odds on that, right? Okay. This guy should have 240 to pass, but of course he doesn't. 150, 232 if we add that up. Likewise, this graduate student, oh, look at that, some good grades there. So what's that? 163 251. Some of them are close, some of them are whatever. But we can look and see, number one, I'm able to do these calculations. I want to find an undergrad student who clearly would have failed, but can verify. Here we go. This guy is just barely passing, right? 81 and 84 is 2 grades, but because he gets best 2 out of 3 and the graduate students don't, this undergrad student passes. Okay, so we can see that, yeah, it's using the correct class-specific version of the method. Now, suppose I wanted to do another thing. Suppose I wanted to have the grades be calculated and displayed in a way that was specific for each class. Well, one thing I could do is use the magic word instance of. Okay, so I'm going to introduce that. Instance of example. So instance of lets you determine whether an object is an instance of a particular class, basically an object of that class or any of its superclasses. So if I say if cm.si instance of uStudent, okay, I can calculate the best 2 grades that way. Else, right, and calculate them this way. Otherwise, use the graduate student version. So I'm just going to copy that here. That's kind of a hassle. I don't want to do that. Okay, so if it's a graduate student, I'm going to have a variable int sum equals this. Okay, I'm just going to sum them up. And I can include that. Otherwise, otherwise, it's going to be used the same way. I'm going to use the best 2 of 3. So I'll say if cm.s exam1 is less than, again, all these, exam2 and is less than exam3, then again, sum equals, okay. And for the next one, very similar. And for the last one, we'll just do else sum equals exam1 plus exam2. Okay, so again, for this one, if the first exam grade is lower than both of the other 2, the sum is going to be equal to the second 2. Otherwise, I'm going to flip around the 2's and the 1's here. So if 2 is less than 1 and 2 is less than 3, then the sum is going to equal 1 plus 3, right? Because I'm dropping out exam 2. Otherwise, the sum is going to equal these 2. And if it's a graduate student, then I just include all 3. So I can include that sum here. Okay, I'll just say s plus equals another tab character plus sum. Okay, so, and I'll do a header as well. So let's do system.out.println name. Probably going to need, let's see, I'm probably going to need 2 tabs for that. Maybe just, well, let's see how it goes. Name, and then a tab, and then what, exam 1? Yeah. Tab, exam 2, tab, exam 3, tab, grade, tab, and then sum. See how that goes. Boom. Okay, good. That's tight enough, I guess. Oh, grade, where's, yeah, I did need an extra tab to start with. Okay. Okay, good. Everything's nice and lined up. So I can verify, look, this undergrad student has its has the sum 169, so he passes. These guys, they come just a little short, right? 238, nope, not good enough. These guys, where do I find it? Oh, here's a 240 for a graduate student, right? Just barely passes. You can see the average there. Okay, now the nice thing about this, again, I can include other student types, right? Now, if I have another student type, for example, that I want to include, so not an undergrad, not a graduate student, but suppose I have a non-degree student, right? So class non-degree student extends student, right? And this one, well, this one, he's not going for a degree, so he's not terribly worried. He's just kind of taking it for fun. So whatever, we're just going to call that one, maybe they're just auditing, right? Let's leave it that way. So A for audit student. And just listening in, they take the exams, they do the stuff, but their grade is not meaningful. So we can just say grade equals, what do we give let's give them an N for not calculated. Okay, so if we have some other class that we want to throw into the mix, we can do that. We don't need to radically change our code. So here we have, again, a new student type. If in our class manager, we wanted to put in this new student type, sure, we could, right? So instead of doing a next Boolean, we could do a next int, right? So we could do this. So let's see, int type equals r.next int 3. Now we have 3 types, and say if r equals 0, else if r equal, type equals, okay, so type is 0 or type is 1, and last else if type equals 2. Okay, I say cm.s.i equals new a student, okay, and cm.s.i.name a student plus I. And then that's all I have to do, right? The grades are still going to be computed correctly. So they'll all take all the exams, they'll all compute it. But if it's an A student, then at the end here, right? In this case, I have instance of U student. So I'll say else if cm.s.i instance of G student. That works one way. But otherwise, I can do else if cm.s, right? I'll just say else here. Otherwise, we know it's an A student. Else some, yeah. I can just leave this, right? I could do it the same way. I'll go ahead and do it this way though. Fine. So it's separate in there. Okay, but the point is, most of the program, right, except for the few tweaks I got to do because I have this new student type, right, and I want to include a potentially separate grade calculation method. Yeah, other than that, it all remains the same, even though I've implemented a new class. So I can still run it. Look, now I have some A students, and the A students, they all get grade N. Okay, so I know maybe this is not terribly exciting to people, but the point of this, again, if you are an enterprise and you have a bunch of classes already written and you want to add in some new class into your system that incorporates some extra degree of data that you didn't previously have, the point is it's fairly painless to implement that new class in a system of arrays that already include that, right? It's much easier than, say, having to write a separate array for every new separate type and write separate code, making sure that that array does the same stuff in the same way as the other things. Because the programs that the enterprises use, they're much bigger and more complicated than this. There's a lot of stuff going on. Okay, this is pretty simple. But this is a wonderful and helpful thing at enterprise scale. All right, so I'm going to quick zip through the relevant slides on this. I guess some of the rest we'll save for Friday. And then any time left over on Friday, we can talk about topics of your choice, I guess. people have questions about the homework, we can discuss that. Okay, so again, returning to our case, suppose we want to implement a class roster. It contains both undergrad and graduate students. Each student's record will contain the name, some test scores, and the final course grade. And the formula for determining the grade will be different for the different student types. Now, there are two ways to design the classes, right? They could be related or unrelated. Now, the way I chose to do it is they were related. There was some superclass student. We didn't actually make any student objects, but it had two subclasses, G student and U student, and eventually A student. So that's the similar thing they did here. So each of the separate classes I made, U student and G student, they had the same data because they all took the same 3 exams, but the grade computation was different. Likewise, the grade computation for an auditing student was going to be different as well. They weren't going to get a conventional letter grade because they're just showing up and watching, basically. Okay. So this, right, zips ahead a little bit. Some of these things we've already covered. So the class roster, we put everything in one single array using the student type, which we saw, right, in our code here for this. Of course, we had an array of type student. And again, that array only contains objects of student subclasses, not student itself. Okay. So again, different elements in the array. Some of them are graduate students, some of them are undergraduate students, some of them are auditing students. Okay. Now, polymorphic message. This one, whenever I call the compute grade for any element in that array, the compute grade method is going to be appropriate to the type of that object. So if the thing at object at index I is an undergrad student, going to call compute course grade undergrad student style, going to drop one of the grades. If the thing at index I is a graduate student, I'm going to compute it the graduate student way. And in some cases, again, if I wanted to, I could use the instance of operator if I need to handle things separate in a different way for different object types. So for example, down here in my code, I had this. So I wanted to display the sum differently for different types, right? So for an undergrad student, because they only keep 2 grades, the effective sum that I'm going to show is just the 2 highest grades. But for the other 2 classes, I'm going to show all the grades. Okay, now if I had done this, right, if I had done, well, these are the same, but the IDE isn't smart enough to recognize that I'm definitely going to have one of these course types. So it's going to either be an instance of, if it's going to be a U student or a graduate student or an A student, we know it's going to be one of those things, but the IDE can't figure that out. So I have to include this catch-all else to verify that sum actually gets assigned a value. Otherwise, I'll get errors later on. Okay. Now, I'll have some more stuff about visibility we'll cover in a bit, but I want to talk about this, abstract classes, because it's relevant here. So an abstract class, remember, is a class that you cannot create objects of, or as they say here, you cannot create instances of it. So if I were, for example, to create student as an abstract class, public abstract class with the magic word abstract, I could do that because I haven't actually created any objects of student anywhere, right? Even though I create an array, Java knows, okay, even though I can create an array of type student, if student is abstract, I can't create any student objects in it. Okay, so that's a little weird. So yeah, I can have this array, and every element in this array is basically going to have the format that's defined by the abstract class student, but I can put in its subclass objects, but I can include its subclass objects. Okay, so A or G or U or A student objects. Okay. So that's it. An abstract class, the reason why you would do this in this case, it's not going to make my code run any differently, right? I haven't created any students, so the fact that I'm denying that possibility here doesn't really change anything. The one thing it does change, right up here I can say, if student is abstract, it means I can't create objects of student. Ever. Can't ever do it. Which here doesn't make a difference. But for the reason why you might want to do that is because why? Suppose that as a general policy, you don't permit students to not be one of graduate or undergraduate or auditing students, right? You say, yeah, you got to fit into one of these. So if you're saying there's no way that by policy our organization would permit a student to be just a generic unspecified student, then the abstractness of this class will help enforce that policy. That's the practical reason why you would do it. All right, so for example, we have here, if a student has to be an undergraduate or graduate student, yeah, you might as well define student so that no objects can be created from it, right? Because why would you want to even let that happen? That could really screw things up in your system. Somebody makes a data entry error and lists somebody as not undergraduate or graduate, just regular student, your code permits it, things could go off the rails. On the other hand, if student doesn't have to be undergraduate or graduate, if it is possible to just be a student or some other class, one possibility is you make the base student class instantiable, right? Not abstract. You just make it like a regular class, and then you can have students. The other possibility is you leave the student class abstract and add a third subclass called other student or something similar to handle a student who's not an undergrad or graduate student. So in my case, I said, well, you could be an undergraduate or a graduate or an auditing student. We cover those cases, but we still left student as an abstract class. So in general, which approach is best depends on the situation. The practical thing in general is if you don't want to ever permit the class to be created as an object, again, if as a matter of policy, your organization does not permit students that are not one of those three types, then there's no reason to allow your program to permit that sort of object to exist. Other than that, it usually doesn't make a whole lot of difference. So, I mean, obviously, if you want to have students permitted, then sure, you would not make student an abstract class. And if you specifically didn't allow them to be permitted, then yeah, you might as well make it abstract. You don't have to, but why take a chance? Okay. And that's it, a little bit here about interfaces. So again, interfaces, which we've already seen, are a special case, special kind of abstract class where you can share the methods with other classes. Okay, so it's different. So remember with inheritance, and take a minute to do this, inheritance always follows down a tree from object, right? So your base class in Java is always, always, always going to be object. And then you could have other subclasses from that. For example, student is a subclass of object. And in my code, we had our three subclasses there. Okay, we had three subclasses of student, and that's fine. But there's always going to be stuff inherited just from one point in the tree, right? So I can't, for example, whatever other class is over here, I can't inherit from this because that would create a lot of really weird potential problems. If, for example, this class also had an exam 1 and student had an exam 1 field, which would these inherit, right? So the fact that different classes can have variables of the same name, by itself, that precludes just simple inheritance from multiple classes. Right? You can't do it. You have to only inherit in a straight line, you know, going straight up to object. However, with interface classes, I can borrow their methods. Even though I'm not going to borrow their data, I can say, this guy, this interface class has a list of methods, method 1, method 2, ... method n. If I want to implement that interface, yeah, I can do that, and I can run those methods in the same way that the interface class does. So, you know, the same format, but of course I'm going to override them. So here, can in a sense borrow the methods, but it's not really going to, not really inherit them. I can use them. We've seen this when we did our GUI designs. So we, for example, use action listener, and then we get that include that action performed method in the same format as the interface class does, but we don't really inherit it. So what happens, in fact, in the case of action listener is that where normally if somebody clicked on a button, it would call the interface class's version of action performed, but instead it sends along the same information to whatever GUI class is using that action performed. Okay, so that's a quick intro to abstract classes, some of these other things. We'll come back on Friday. We'll talk about visibility, but let me ask, any questions on any of this? I know people have not been much for asking questions this week, but if you have any, not just you, it's been kind of across the board. Nobody's got any questions. Everybody understands everything, I guess. Maybe we're to that point in the semester. I don't know. Any questions on any of the stuff I covered today? So the key takeaways, all right. Number 1, building arrays of a superclass and including objects of the subclasses. And number 2, the instance of operator, which basically checks, is this thing that I'm looking at, is it a member of such and such class? That's pretty much it. And then we talked about abstract classes a little bit. Just a quick introduction to those. All this makes lots of sense. We're all good enough. All right.